Steve Stein from Pisces, Joe Weiss from Applied Control, and we have Laurie Ross O'Neill from the Pacific Northwest National Lab. We will start from Mr. Daniel Brown from CISA. Mr. Brown, the floor is all yours. Thank you.
Okay, I will share my slide deck again. And let's see. Let's go from beginning. Okay. Are you able to see the slide deck?
Yes.
Perfect. Thank you. So again, I'm Daniel Brown from CISA. I'm based out of Spokane and I cover Eastern Washington. I'm just going to give a real quick brief on CISA services and Volt Typhoon PRC. So go ahead and start right in. Volt Typhoon, this is just it's a busy slide with a lot of stuff, but it just talks about how the PRC is targeting critical infrastructure, including water, wastewater, energy, transportation, and any of those critical sectors involved with that. So they are PRC nation state sponsored. They're under a bunch of different aliases: Vanguard Panda, Bronze Silhouette, Dev 0391, and there's a handful listed. They talk about employing living off the land techniques to provide minimal footprint and to lie dormant. They're adept at full domain compromise, leveraging valid accounts for stealth and focus. They maintain persistence, in some cases for years. The intent is to maintain persistence and to disrupt our critical infrastructure at a point in time that is most beneficial to the PRC. Say, for example, if they did ever decide to invade Taiwan and they could take down some of our water systems, power systems, etc., that would be the point in time that they would do that. So, there was a cybersecurity advisory from a whole bunch of federal agencies and also GCHQ, Australia, Canada. They all signed on to that to state this as an extreme threat. They also had another advisory talking about living off the land and how they're using that to evade detection. So they'll use things like PowerShell or any built-in functionality of the operating system to kind of mask their presence and activity. So this is a really cool slide, but the takeaway is that there are 4 stages: the recon, the initial access, which is how they get in, whether it's phishing or however, but they get in, they use those credentials, then they do lateral movement, which can include privilege escalation. If they just have a baseline user, they try and escalate to administrative user, and then the potential impact is what they can do when they decide to activate. Just an example of Volt Typhoon, China-based hackers were able to affect a Texas military site. They inserted malware into systems of water and electric utilities that serve a base and serve installations in the U.S. and abroad. So it is real. It is occurring. And yeah. So methods to evade detection. Basically, what they do is they'll camouflage their malicious activities with regular system behavior. Like I said previously, using things like PowerShell. They'll clear the logs. They'll do log and artifact clearing. So they'll selectively erase Windows event logs. So they won't erase all of them. They'll just erase the ones that show where they've been in. So you wouldn't notice it at first glance. They'll also use file name masquerading. They're also file names to mimic legitimate files, so they can remain unnoticed. How to defend. PRC state-sponsored actors compromise, maintain persistent access. So how to defend, basic 4 steps. These are common amongst a lot of CISA presentations and recommendations and others. Apply patches for anything that's internet facing, prioritize patching critical vulnerabilities, implement phishing resistant MFA, ensure logging is turned on, and plan end of life for technology beyond manufacturer supported life cycle. Now, in an operational technology / SCADA environment, that's not always easy, but then you need to have compensating controls to, if there are vulnerabilities for something, you need to be able to segment them off and make sure no one can get to them from the open internet. How to defend, maintain an inventory of both your IT and OT devices, know everything you have, segment your OT network and use controls to protect. When you're using VPN, define access. So, when they VPN in to get to an OT system, they should only be able to get to that system and not have any lateral movement. Use the Purdue model where available. I have another slide on that. And monitor your status of OT network and look for anomalies. You can use tools, log aggregation tools like a SIM or Splunk or something like that. That's just an example of the Purdue model. It is a way to properly segment the IT and OT networks using 5 levels and greatly control access and limit it. For example, a finance computer should never be able to directly access an OT computer. So this is what CISA does. We're 80% prevention. We'll come out and we'll do assessments. We'll help you analyze what you have and prepare, and 20% response. If you have an incident, you can contact us. We can assist with talking to other federal agencies, FBI, Secret Service, however, and we can assist with some of that and help out there. And that was what I have. I hope I went through it. My contact information is there. Again, I am based out of Spokane and cover Eastern Washington and those 20 counties. So.
Thank you, Mr. Brown.
No problem. Thank you.
Any questions for Mr. Brown? Okay, let's proceed to the next speaker, Mr. Wordell.
Right, I'll look to do a share as well. Kind of winging it here when Brad called, said, "Hey, can you present?" Thought, well, what am I going to present? So let me talk to you about what we're doing here in the city of Spokane. All right, so if you haven't seen a beautiful picture of downtown Spokane, this is the river, and we have water, we have wastewater, we have wastewater treatment, and as most municipalities that have a river know, you get the privilege of protecting the river. So it's one of our most precious resources, and when you look at dollar spend, it is as well. By the way, that picture was taken by one of our attorneys who also does photography on the side. I really appreciate his work. James just retired last year. All right, so cybersecurity, wastewater. I'm going to talk about some of the things that Dan Brown just mentioned. So I appreciate that segue, Dan. My name is Dan Wordell. I'm the Chief Information Security Officer for the city of Spokane. I'm 9 years in this role here with the city, and it has been a long walk, but also one that's rewarding. We have lots of critical infrastructure. So I'll talk a little bit about I'm going to focus on wastewater because we have 5 SCADA environments, and we've got to pick one. We'll focus on the wastewater, talk a little bit about the state and local cybersecurity grant, because we've been leveraging that to get additional funding in. Talk about frameworks, because if you're going to do security, you should be following a framework or a model. I'll touch on the Purdue model, and as Dan also kind of mentioned it, inventory. All right, so cybersecurity, I'm saying it's a shared responsibility. This is an interesting map. It was developed about 10 years ago when we were expanding our wastewater treatment plant. And on the east side, you see a Spokane County river water reclamation facility. And when that plant doesn't work right, it flows into our plant. So on the west side of this diagram, you see the city's Riverside State Park water reclamation facility, and we process 34 million gallons of waste a day if nothing happens On an event day, it can go up, the plant can handle 150 million gallons. But on a big event day, that exceeds our capacity. And so the city has built 20 combined sewer water overflow tanks that are on the edges of both sides of the river that capture that water and keep it from going to the plant until the plant has capacity to process it. So it's one of the interesting things when we talk about industrial control systems in the city. This is a very large environment and relatively new. All right, so here's a nice shot of our wastewater treatment plant, and I have a couple other diagrams that I'll come back to. But this plant, since it was implemented in the 1950s, has been under construction. And the latest construction is what you'll see on the lower right-hand side of the document, our membrane facility. That is maybe 5 years old, in production only a few years. So from an industrial control system SCADA side, it's brand new. And it is a fabulous facility to walk in, but it also has an immense amount of technology that runs in this plant. All right, so let me touch base on my projects. We leverage the state's, it's a federal program, the State Local Cybersecurity Grant, SLCGP. And we made requests for the water department, for the wastewater department, and the wastewater treatment department. And from a cybersecurity perspective and your security officer perspective, I'm looking at where our risk was. And we've brought in the state auditor. They've spent some time with us. And one of the things we identified was a Cisco switch that's been running on the network for 9 years, and it hadn't been power cycled. Now, from the industrial side, you might say, that's fantastic. Look at its runtime. From a cybersecurity manager perspective, I'm going, oh my goodness, if that device fails, what's downstream and what's going to get impacted, and can you replace it? So I really look at resiliency from the cybersecurity perspective, and we're leveraging in difficult financial times this SLCGP grant to replace all of the switches in our wastewater treatment plant. So that's really the focus of what I'll go into. I do have a sense of humor, and human error is where many of our challenges can lie. We can have the best firewalls and encryption and antivirus. Dave, if you're on the call, I apologize for using your name. Human error is one of the things we combat with good systems redundancy and good training. The framework, again, I said if you're going to deploy a system, you better have a framework. We follow the NIST cybersecurity framework, NIST CSF, and the CIS version 8.1, which used to be the top 20, now it's the top 18 controls. That can be daunting if you're trying to do all of this. So I'm going to shrink it down a bit, and let's just take a look at the top 6. Well, actually, let's look at the top 2. Asset management, inventory. If you don't know what you have, you can't protect it. And that was one of the greatest challenges when I went to the plant and said, hey guys, let's talk about what you have on your network. I want to know where it is, what it is, its function, its OS level or firmware level update, and they couldn't give me a good inventory. So I've been working with them to say, not only do I need an inventory, but it needs to be amazingly accurate, and then we'll find out where the risk is. We have had a couple of audits that we've called in. So the state auditor's office has come in and done an audit for us. CISA has come in and we did a physical security audit. So we looked at the porousness of our campus. But it all came down to, what are we protecting? And on that cybersecurity side, I'm going to say your inventory of your hardware and your software. If you can get these two down, you've gone a long way in maturing your cybersecurity program. I touch on the Purdue model as well. They said we have 5 systems in the city, and I'm going to tell you that nothing inside our industrial control zone gets to talk to the rest of the world. You probably are familiar with jump boxes where you can jump in and you might get a view of something, but you don't get a direct connect to it. So we follow this, I push it, and then give you a little history on the city of Spokane. We're a Cisco shop, we're a Microsoft shop. This is also the Purdue model. And you'll look up in the top left here, you see a dotted line and an X going to, not recommended that we would put, for example, Factory Talk, and we're a Factory Talk shop. You don't put your client view outside onto your industrial enterprise network, and then assume that you're just going to get a view in. So for the city, we have all of those industrial control systems located on layers 0 through 3. We do have an industrial DMZ and IDMZ, and in that environment, we have a very secure third-party vendor access solution with multi-factor authentication. We record their session. They can only get to the boxes that they're supposed to get to. And we also have a SIM tool deployed, and we put that collector in this industrial DMZ. Critical systems that are down in layer 2 and 3 of our plant operations in the SCADA and PLC networks can send logs to the log collector in the IDMZ, and they just sit there. And then our SIM tool can pull from there, but no traffic directly traverses that DMZ. It has to land and sit and then be pulled. So we're following this Purdue model. This is in production. It's a large environment. And so when I pushed our group for inventory, it took me almost a year to get this list. And it changed over time as they reminded themselves of what they had. And I said, we're a Cisco shop, Stratix, which is rebranded Cisco for industrial environments. We're a factory talk shop. Well, I guess that's kind of the high level. We have 2 primary networks we're supporting at the wastewater treatment plant, the SCADA network and the PLC networks. That PLC networks go down to layers 0 and 1 in that Purdue model, and the SCADA network being on layer 2 and 3. So we've got this SCADA network, we've got a PLC network, we had all these switches, and we needed a way to replace, because in most industrial environments, you deploy technology, and that technology may run for an excessively long period of time. 5 years is not the normal. That's an IT thing. But on the OT side, you can have equipment and technology that runs for 10 years, 15 years, 20 years. But in some cases, some of these switches were getting old enough and not supported by the vendor, and we didn't have spares anymore. That became, we had a risk. And if I talk too long, give me a hand wave. I can see a couple of people here. So if I need to cut short. Again, I have a sense of humor. If you have Internet of Things devices, if you have that refrigerator that talks to you, it doesn't go on your SCADA network. You also have to remember to smile and laugh and enjoy life. All right, so that's my mushy side. Finally got a network diagram from our guys here, and they could lay out their different fiber rings. And I'll come back to the picture of the plant because it's kind of interesting where it covers. We now have control rooms of both ends of the facility. We have fiber going to both control rooms, 10 gig links. We have mirrored sets of servers in both locations. And in fact, if anybody on the call is a Rockwell customer, just 2 weeks ago, week and a half ago, Rockwell pushed out an update. They said it was verified and tested, and it took down our SCADA system. We lost full control just less than 2 weeks ago. Fortunately for us, we had an old server, a ghost server, that was running on older software. We were able to fall back to that, continue to run the plant, and do a recovery of our Rockwell Factory Talk system. It was a very exciting day for us. We hope we don't have those issues very often, but one of the things that I don't have time to talk about today is third-party risk, vendor management, and holding your vendors accountable, not only in your communications with them, but in your contracts. That's a whole nother topic. All right, so here's our plant. And for those of you who follow wastewater, yes, we have. It comes into Headworks on this far left and starts flowing through all sorts of systems. Now I'm going to show you a picture again of the plant. This really does mirror the physical. Here's the first picture, the things on the north end, get farther to the south end. This far right-hand image is our membrane facility, which is removing all sorts of chemicals that would, before this was in, just got discharged into the river. And looking back here at our plant, it actually discharges not quite as that flow diagram is, but flow diagrams are important to have too. This flow diagram was actually designed in 2014 when CH2M Hill, our prime contractor, was contracted to help build and implement this facility. So this has been a long journey in getting our wastewater treatment plant and the water membrane facility online, and a significant amount of technology. So in the green building here on the far right, we have a backup data control environment. And way up to the left, there's a white building at the very far north end. That's where the primary control rooms are. And they can fail off between these. We are also a Nutanix shop, so we have Nutanix clusters in both locations with mirroring of these servers. So we've got a lot of redundancy. Resiliency is a theme I keep bringing back up to the staff. Don't tell me how good you implemented it. The day it gets attacked, and Dan has mentioned attacks from state agencies, state-on-state attacks, whether they want to attack water, wastewater treatment, they could disrupt our operations. So our point is, if the attack happens, how quickly can we stand back up critical operations? Yes, we can go manual. Oh my goodness, I hope we never have to go manual. People are going to be running all over this very large facility. Looks like I have some other stuff in here. Just a high point, cities are being attacked on a regular basis. Columbus was attacked. This was on their enterprise network. Just here last week, City of Mission in Texas was attacked, and they're under a cyber incident right now. Again, it's on their enterprise network. But the point being, municipalities, cities, counties, water districts are a focus. The adversaries know where we are, and they are looking at our network, so build resilient systems. I don't need to go into that. All right, we'll finish with, it's not trust but verify, it's verify before you trust. If you guys would like to know more about the City of Spokane system, I can share that. I always leave with the mushy side. Take time to care every day and protect yourself. And in my case, I say the City of Spokane and our citizens. And I appreciate your time. I'll end with our nice picture of our downtown and one of our dam shots, metaphor there. And I thank you for your time.
Thank you, Dan. Lori had a question, and the question goes like this: what do you use for your vendor access capability?
Vendor access capability, we use a product called SecureLink. It was just purchased by a company called Imprivata. And we have a gateway in our DMZ, corporate DMZ, so that's where most of our vendors go. We also have a secondary gateway in the IDMZ, and any vendor that comes in has a two-factor authentication into that. They land inside the zone, and then they can get to the one and single system usually that they need to get to. And they get a view only. They don't get our passwords. We protect that, so we can grant them access and turn that on and off on their at the point of their request. Record the session, and then when they leave, they shut down their session. So Imprivata is our tool.
Thank you so much.
Very
so
tightly managed.
Oh, interesting. Is it like a third party where they meet in cyberspace, or that's a product you actually install in your environment?
That is a product. I'm a firm believer in on-prem. So okay. I'm not necessarily a big believer in give it to the cloud and it'll be okay. So we actually have gateway servers installed in those DMZs, and we manage that environment ourselves. So it's in-house from that perspective. When we set up a new customer, if somebody says, hey, I need a vendor to come into the space, it's not fast. We need to get with the vendor, understand their network, understand the systems that they're going to go to and the protocols that they're going to need. And we set up a custom connection for that one vendor so they can see and get a view of the one system they need to have access to.
Thank you. I appreciate that.
Thank you. Does anybody else have any question for Mr. Wordell? Oh, thanks again, Mr. Wordell, for the presentation.
My pleasure.
Okay, Steve Stein from Pisces, you're next.
Hi, I'm Steve Stein, Executive Director. I'm going to bore you with my face because I do not have a slide deck to share. But I wanted to introduce Pisces to those of you who don't know. Dan is actually on our board, so he's already familiar. But Pisces is really a very simple program started a number of years ago. Kind of as an experiment. And the focus of it is to try to do two things. One is to work with students who are trying to get a degree in cybersecurity and go into the field to provide them with operational experience. And we do that by working with small communities, typically rural, generally less than 150 people on their network, who agree to share the data, metadata only, And that gets streamed live to an analytics stack hosted by Western Washington University. We're in the process of building a second stack at Spokane Falls Community College. And then we provide the students with secured access to that. The students prowl that data to identify events from the various communities that are sharing information. And when they identify an event, they write a ticket, and then they do research on it and try to verify and validate it. We have a cybersecurity professional in the background who is reviewing what the students do, validating their work, or coaching them in the process. And then those things that rise to the level of informing the communities that there is either a threat or a weakness in their network that they need to take care of. We reach out and talk to them about that and make those adjustments. So it's really pretty simple. Started with about 7-8 students at Western Washington University. The next term, it had about 32. This is all information that was shared from student to student, because the students really grabbed the notion of combining their theoretical work in college with the operational experience. They found it to be extremely valuable, and the program has grown rapidly and substantially. This year in Washington, we're probably going to have about 600 students go through the program. There are 25 data sharing partners in the state. We have 11 academic institutions that are supporting the program. They don't all teach at the same time. Typically, there's 4 or 5 that teach any given term. So that's the essence of the program. Pisces provides the infrastructure, the professional services behind the wall. We provide the curriculum to the academic institutions at no cost. The program had been funded. It was created initially and funded by DHS CISA, with active support and partnership from Pacific Northwest National Lab. That's about to end in June. So the model is kind of simple. It's to work with a state to get them to fund the operations, and then we grow the capability in state. Washington is our biggest footprint. Initially, we didn't really think about expanding beyond Washington, but now we're actively looking to expand into New York, Hawaii, and Montana. We were in Kentucky and Colorado, and they have since launched their own enterprises that are quite different from us. But we're built on that foundation. So that's sort of the short version. And I'll just let it sit there. And if there are questions, I'd be happy to answer those.
Thank you, Steve. Does anyone have any questions for Steve?
Well, that was easy.
Well, I have a quick question for you. You mentioned it's expanding to these other states, which is amazing. Congratulations on that. So if your funding is ending, how do you sustain this?
Well, that's kind of the beauty of the partnership. So CISA initially funded it, and they funded it for 5 years. The idea from the very beginning was to get it to a sustainable enterprise. So Pisces is a small nonprofit. We aim to keep the costs really low and have low margins. But through CISA support and PNNL support, we've been able to build the infrastructure and the support systems that we need to allow this to go forward. And then what we've done is we've gone to the states and basically explained what Pisces does, laid out what the cost parameters are, and the states going forward will be the ones that fund Pisces in their universe. So Washington State is paying for Pisces in Washington State. CISA, with CISA funding, we had been allowed to try to recruit some other states, and that's allowed us to go into New York and Hawaii and Montana. The CISA funding will end in June, but we have financial commitments from at least Hawaii and New York to begin the program there starting June. So between the footprint in Washington State and the toe prints in those other states, we have the financial wherewithal to continue to build and grow as long as nothing dramatic happens. Does that answer your question?
Yes, very much. Thank you so much for sharing that. I think it's a great program, and I'm glad to hear it's expanding.
Thank you once again, Steve, for the presentation. So up next, we have Mr. Joe Weiss from Applied Controls. Mr. Joe.
Okay, thank you. Can you hear me?
Yes.
Okay, I don't have any slides. What I've been doing is listening, and I want to kind of, wrong term, but respond to the presentations that have occurred to date, and basically what's missing. What I look at is I'm the engineering side of cybersecurity. Everything that's been discussed has been the network side of cybersecurity. I'm the side that we don't have any cybersecurity in, and we have to figure out what to do about compensating controls. So what we're talking about are process sensors, where you measure pressure, level, flow, temperature, voltage, current, chemistry, you name it. Variable frequency drives, motors, pumps, valves, actuators. This is the part that's almost always ignored. This is level 0. Okay, now a couple of things, and I apologize for rambling. What I'm trying to do is respond to what I've heard to date, or what I've heard so far. In the initial presentation, it talked about, Volt Typhoon. What hasn't been addressed, and is a big deal in Washington, are Chinese transformers, because we do not know what's in them. One of them was basically destructively examined at Sandia. The report on what they found was classified as top secret. Think about what that means, okay? The other thing is the initial presidential executive order on the Chinese transformers, 13920, explicitly excluded all of the networks. It excluded everything that would be considered normal cybersecurity. Why? Because the Chinese were bypassing all of our networks and basically are going to spoof the sensors to be able to take over the equipment. Nothing of this will you see on any of your network monitoring. The second thing is, I wanted to bring up, Dan, when you had brought up the Cisco switch, just as an interesting sidelight. Years ago, I had a case where a 2-unit power plant, when they restarted a particular Cisco switch they hadn't used for quite a while, literally took out every single processor in their distributed control system. This was almost incredible to be able to fathom that that could happen. And we found out it not only happened in a 2-unit power plant, it actually happened in a nuke, in chemical plants and others. Now, was that malicious? No. Was that devastating to totally lose all your microprocessors? You're talking about going totally dark with a facility at power. And if you have a digital safety system, you've also lost all safety. This is, I can say, this was real. I actually had the technical manager from the utility that happened give the presentation. So this isn't third party. I noticed that you had mentioned that you're isolated and you're not going to be able, nobody's going to, from the internet, da-da-da-da-da-da. I actually had an assignment a number of years ago. It was also a wastewater facility. They were replacing all of their old analog 4 to 20 instruments with brand new digital. And they thought they had everything isolated. and I was there to give the good housekeeping seal of approval. It turns out when I asked, whose sensors did you put in? All I did was went to their website. It turns out the only way to calibrate those sensors is over the web. And by the way, this is where we are today. All of our sensors, regardless of from which vendor, have no cybersecurity, no authentication, no cyber forensics. And oh, by the way, your Pisces program doesn't address this because this is at the sensor and actuator level. This is where we have no training at all today. And for what it's worth, the reason I come at this, I'm actually a nuclear engineer that got into cyber. So what I was doing for so many years was the safety of the sensors and actuators having to meet NRC requirements, which is how I found all of these things. Also wanted to mention, there's been more than 150 control system cyber incidents in water and wastewater. These are control systems. This is not ransomware. This is not IT. Almost none of them were identified as being cyber related. In one case, they had 3 water hammers in the span of like 4 or 5 days, all from SCADA. None of this was considered or identified as being cyber. This is really big things. The other thing was I wanted to point out about 3 weeks ago, no, it was February 19 and 20. The state of California, actually InfraGard, had a water cybersecurity summit. It was in LA. I joined virtually. And it was the FBI, CISA, EPA, and the utilities. There was no presentations or anything else from vendors. And the point being, I was the only one asking about sensors. And I finally got, and the response to me was, we'll get back to you. So the following Monday, I got an email from EPA Washington. And their response to me was, oh, just use standard IT cybersecurity. This doesn't work, period. The other thing I wanted to point out, it's something I got yesterday. Okay, this is, if you will, the other side of the street. You're all talking as network people. Don't ask me why I got it, but it's from a water utility in California, and it's a brochure. And it's basically, they're recruiting junior and senior level engineers for the water utility. And I just want to read you what's in here, because what's important is what is not in here. It says, assist with or lead in providing electrical engineering and technical support to ensure reliable operation of the agency's SCADA-controlled facilities, including remote terminal units, RTUs, programmable logic circuits, PLCs, programmable automation circuits, PACs, associated industrial communications, networking equipment, and protective relaying equipment. What was not mentioned in any of this? The word security. The engineers and the network people do not work together. It's broken. It doesn't work. I'm writing a paper for Sam Houston State University as we speak on what should be in the curriculum for control system cybersecurity. Not the term OT, because OT is only the networks. This is what's missing, and people simply don't want to listen. I'll give you one last one. beginning of February, CISA was giving a course on control system cyber. It was basically going to be in North Dakota. So I sent an email asking CISA, will sensors, actuators, and drives be part of the course? The email I got back was not from CISA. It was from Idaho. I have the email chain. CISA didn't know how to answer, so they sent the note to the Idaho National Labs. The response I got back from Idaho was that the controllers and the devices, that are feeding the controllers were not part of the training. That's from Idaho. So I'm sitting here and just trying to point out, if this is supposed to be about critical infrastructure, we're missing the part that makes it critical infrastructure. What you're looking at is simply the things that make it a network, which could just as easily be your front office as well as, as quote unquote the OT. So I will apologize if it came out at all in any way, shape, or form wrong. But the point is, after 25 years, because for what it's worth, I started the control system cybersecurity for the electric utilities in 2000. And when it comes to the actual sensors, actuators, and drives, we've gone backwards since this was started in 2000.
Okay. Thank you, Joe. Does anyone have any question for Mr. Weiss?
Can I make a comment based on what you said from my experiences with INL?
Sure.
So 2 weeks ago, I was at INL for an industrial control systems training, and they do offer some training. We did a red team, blue team exercise, and we had folks on teams that were directly attacking ladder logic and getting into the PLCs. So there are trainings that kind of address it. I agree and understand there's nothing specific to, but they do tangentially get there. And it was a great training. I'd recommend it to anyone. But
yeah, here's the point. And again, it comes because of my background. And by the way, part of this was supporting PNNL when I was still playing nuclear. Okay. The issue is what you're not addressing is the input to the PLC. The PLC will do exactly what the sensors tell them. If the sensors are off, the PLC will be off. This is what the Chinese are looking at. If they send a spoof sensor signal, unlike the network world, we are 100% trusted. We are not zero trust. There is no way to know if that pressure or temperature or voltage or current reading is coming from a sensor or Beijing.
Okay. Thanks once again, Mr. Joe Weiss. Okay, our last speaker, Laurie Ross O'Neill from the Pacific Northwest National Labs. Laurie, the floor is all yours.
Thank you so much. I'm going to hopefully get my slides going here. I just have a couple. I want to share some work I've been doing. Hopefully you'll see it in a picosecond here. All righty. Hopefully everyone's seeing that. So I want to talk to you today about how would we share information about cyber events or cyber weaknesses that are being detected across the highly connected infrastructure. So all of us here have interest in the connected infrastructure. I've heard about wastewater, I've heard about nuclear, I've heard about electricity, solar. So we all have that in common. And one of the things that PNNL was tasked with was who would be willing to share that information, not necessarily with the government, but some type of member-driven organization. So the type of highly connected infrastructure I'm thinking of is electric vehicle charging. And I don't know how many folks are familiar with the electric vehicle charging infrastructure, but if you look at this picture, you can see there are a lot of areas or industries that are connected to it. Not water yet, but I think at one point it could be. But solar definitely could be. Obviously, we've got payment, we've got PII, we've got IT infrastructure, we've got the vehicles themselves, we've got the roads and the transportation systems, we've got energy, we got the mobile apps and comms, and that's all different pieces that kind of make up what we're calling electric vehicle charging infrastructure or electric vehicle ecosystems. And so we've been kind of grappling with, well, where does responsibility lie with that information sharing? And one thing we're realizing is that there is a really low barrier to entry into this area. I've gone to a couple conferences on electric vehicle charging and electric vehicles, and it's amazing the folks that are being involved with this. I'm everyone from electrical contractors to construction companies. Welding companies are starting to build chargers and installations. Companies that do spooling of wire, companies that do interconnectedness, payment companies. So we kind of did a brainstorming of what kind of companies we think are involved with electric vehicle charging. And it's amazing that any one of these on this list that you're looking at could suddenly be a prime contractor to install a bank of chargers. It just blew my mind. You know, a company that used to build warehouses is now installing electric vehicles, chargers. They're dealing with all kinds of things. Unfortunately, sometimes they're not even including the utilities in this. So it's becoming kind of something that's getting ahead of itself, I think. You know, the term getting ahead of your skis, I think that's really what's happening here. And so what we're also seeing, I'm going to jump to another slide here if you liked interconnectedness. So thinking about the protocols and the connectedness of it, obviously we do have some ISOs associated with that. There's also some different protocols coming about for the charging itself. If you're familiar with the Tesla chargers, they came out with the J3400, which is the NACS protocol. So new protocols are coming out every day about this too. And then we've got the, let's see if I can do a pointer here. So you can see on the left side, we have the internet, we've got wireless, we've got Bluetooth, we've got cellular, we've got lease lines, we've got all different kinds of communication. And that's between the vehicle and the app, the human, the banking system, to the charger itself. And then from the charger itself, we've got the charging system management system, or the management system, the charge network provider, the charging service provider, the utility, the vendors, the OEMs. It's just such a long list of folks. And like I say, it's super low barrier to entry right now. Software companies that used to make, you know, websites are now making apps that control how people can find and charge their vehicles. It's crazy. So that's one of the challenges we've had. And so we were tasked with trying to figure out, you know, if an event occurs, a cyber event, you know, we typically talk about an event, an incident. An event is, in my mind, something that maybe before it becomes something horrible or really bad, it's more of before it becomes an incident. But let's say you are a provider, you're now maybe a city in the state of Washington. You are now installing electric vehicle chargers, banks of them at rest stops or downtown or whatever. And you realize that there's a library that all these folks might be using because you found it somewhere else that you know is suspect. And you're thinking, I wonder if our provider that we contracted with is using this library how would I find out, and how would they ask all the contractors and subs that they have that make up this product? And so how do you ask that question, and how do you get an answer back? And so we're kind of looking at how could that information be exchanged in some safe way. Definitely it could be just put out in the ether, but how do you find those people that care about this topic and would want to be part of that? So you might be thinking information sharing and analysis centers, or maybe information sharing analysis organizations, or there's even working groups or special interest groups, which I think are all great ways to do it. But where does that fall? I'm going to do a couple slides, and I'm going to jump to that topic. I kind of got ahead of my skis there. But so who are you going to call during that event? And so what we started doing actually was, what is the reporting process? Like, who all would be involved if somebody actually identified a weakness in the system? Maybe it actually turns into an incident that needs to be reported. So what we did is we started looking at it at the federal level, and then we actually went to the 50 states and territories and started looking at that reporting process. And as you can imagine, there are 52 different ways to do reporting of an incident or a cyber event. I'm going to apologize for the pink. The person who made this for me loves pink and pastel, so I'm going to apologize for that because I realize it's hard to read. But if you can follow along with me, if something bad happens and we believe there was an exploit occurred, so it depends on who you are in this conglomerate of entities involved with electric vehicle charging, who you're going to report to, as well as how severe it is. Now, I'm thinking some folks may think they know the answer, and shout it out if you do. But if you're electric utility, you actually have to report to the Department of Energy. If the incident is material, you have to report it to the SEC. If it's a covered incident, you have to report it to CISA, of course. And of course, you can always report to CISA. I will say CISA is always the right answer. So don't think you can't report to CISA. But what if it's more anomalous and it's a multi-threaded threat or a multi-vectored threat? Well, you're probably going to report it to CISA, the FBI, the Secret Service, and maybe a couple other three-letter agencies as well. And it gets more and more complicated as we kind of traversed what type of event it could be. And then over here in the right-hand corner, we have the states. And the states, like I say, there's 50 different answers to who you would report to in your state. So it kind of got a little, we didn't find one particular answer. I'm going to jump to the federal level here on the next one. And then I'm going to talk a little more about information sharing. So we talked about it's an event. You probably start dealing with it internally. You have to determine, is it still internal? Is it a mistake? Is it something that really is reportable? We need to escalate it, right? Well, you determined it probably is reportable. So who are you going to report it to? Well, maybe within your state, you have requirements in your state you have to report it to. When I'm talking about electric vehicle charging, there are probably things like the state Department of Transportation, or maybe it has to do with state energy, or maybe it's even the state's office of their CIO. In some cases, the CIO has to be notified in some states. But like I said before, CISA is always the right answer. So at every level, you're going to find CISA, which is good. But then we get into, like I said, the SEC, CISA, some of the other three-letter agencies. Well, guess what? It's a major breach. And like I mentioned previously, then we get into some more three-letter agencies. Well, what if it's a threat actor from another country? Well, then we're going to have to bring in other agencies as well, right? So it gets a little complicated here on how you would report these things. But really, my question is today, above and beyond that, is who could we share this information with before it got to that point? So we talked about all these organizations or these different sectors that deal with electric vehicle charging. And so we said, well, what are some ISACs that exist, the Information Sharing and Analysis Centers? And we came up with 6 of them. There's probably more that could be involved. the auto ISAC, because there's the vehicle itself, the electricity ISAC, because obviously there's a connection to the grid at some point, communications ISACs, the financial services, because we've got payment and PII. We've got the information technology ISAC because it deals with cloud. We've also got the multi-state ISAC because if it is a state funded or it resides in a state property, the states probably need to be notified. And there's probably even more that would be involved. There's also the transportation ISAC. There's actually 249 ISACs that are approved by DHS, and we identified quite a few of them. So that's when we started thinking, do we need a special information sharing capability just for something that is so interconnected? Do we need a connected ISAC or a highly connected ISAC? Was one of the things we were kind of kicking around. And this is us just being our researchers in our own little space, talking amongst ourselves. But these are kind of the things that we came up with. Is there one entity to rule them all? Would there be a safe place for all these organizations to have these conversations to prevent an incident from happening? Could they be sharing the weaknesses or talk about shared libraries or shared resources that they use and try to make that space safer for all? And so we kicked around the idea, could that be an ISAC? Could it be an analysis organization? Could it be a SIG? Or could it be a specific industry group? Electric vehicle charging is not US centric. It is a global issue or a global service, if you will. Every country has it. We might be on the decline, I don't know, but it's something that everybody's kind of dealing with right now. So anyway, that was what I wanted to share with folks today. Just kind of get your juices flowing, get you thinking about things like Joe got you thinking about at the control level. I just wanted to talk to you about what your thoughts might be at how we talk about these and how would we share this information. And ultimately, we're trying to determine, I'm thinking this would be an organization that's run by the members, driven by the members. It's more government out, industry in, but if you have ideas and you have thoughts, I'd love to talk to you. So thank you for your time today.
Thank you so much, Laurie, for the presentation. Does anybody have any questions for Laurie concerning the topic?
Yeah, can I mention something?
Go ahead.
When I left EPRI in 2002, I started the first control system cybersecurity conference anywhere. It was for the control system engineers. It was not for the network people. And it was arguably the only conference anywhere where the engineers would actually share incidents that occurred. And the reason they did it, number one, was trust, but number two, they wanted to know, did anybody else have the same things happen to them? Because remember, everybody uses the same equipment from the same vendors. When I finally sold the conference back in 2015 or so to Security Week, it went away because the trust wasn't there. The issue is, like I say, it was fascinating. The network people never asked and never talked. The only people that did were the engineers because they didn't consider it cyber. They considered it important to their operation of their systems. And they wanted to know, what else was going on. So the issue is, can it be done? Yes, but it has to be done in a trusted way with people who have a vested interest. And often it's the engineers, not the network people.
Thanks, Joe, for that insight as well. Okay, so it's my turn. So I just want to make a recommendation. So just talk about ISA 99. So I'll recommend that everyone on this call try to take a look at the ISA 99 industrial automation and control system security standards. So just a quick overview. It's the ISA 99 Standards Committee brings together cybersecurity experts from across the globe to develop standards, for industrial sectors and critical infrastructure. So I recommend everyone go into this and just take a look, and also try to join as well, because they need people to provide feedback as well to their standards, and also provide peer review as well. Okay, so it's 1 p.m. So that was just our thought. So does anybody else have anything to add to the conversation? Well, I'd like to thank everyone again for attending this first meeting, and we'll have another meeting next month, and as well as May. So thanks everyone, and enjoy the rest of your day.
Thank you all.
Hmm?
Bye.
Thank you.